Hello everyone, so today in this video we're going to be going over some concepts regarding definite integrals. So here's our first problem. The velocity of an object moving in a straight line is given by v of t equals t squared minus 2t minus 3. Find the total distance this object travels between t equals 0 and t equals 4. So note that the question says total distance, so we're going to need to take the absolute value of the velocity function when finding the antiderivative, like to find the total distance. So this can be represented by this integral. And because we're dealing with absolute values, it's helpful to make a little sketch of the function on the side so we know which interval to reflect across the x-axis. So first we can find our zeros to figure out where the function is above the x-axis and where it's below. So after we factor, these are two roots, and because the function is opening upwards, it's positive parabola, positive quadratic, so it's going to have this shape like this. And because we want the integral from 0 to 4 is our upper limit, so we're going to have to separate this into two different integrals. So the first one would be the one from 0 to 3, and we would have to flip this so it looks like this after we reflect across the x-axis. So for that, we're going to need to take the multiply the velocity function by -1. So the first integral would be from 0 to 3, and that would be negative t squared plus 2t plus 3. And then here now we add the original function. 3 to 4, t squared minus 2t minus 3. And now we can use the usual steps and evaluate the integral. So first we have to find the antiderivative of both of these functions. That'd be 1/3 t cubed plus t squared plus 3t. And then we would have to add 1/3 t cubed minus t squared minus 3t. And now we just plug it in and evaluate the integral. So this would be equal to 1/3 3 cubed plus t squared is 9 plus 9 again, 3 times 3, minus, and then because when we plug in t equals 0 into this equation, we get 0, so we can ignore that step. And now we just move on to the next one. So this would be plus, and then 1/3 4 cubed minus 16 minus 12, and then we have to do the lower limit, so it would be minus 1/3 3 cubed minus 9 minus 9. And then now we just have to solve using basic algebra. This would be equal to -9 plus 9 again, so this cancels out. These cancel out. It's 9. And then 4 cubed is 64, so plus 64 over 3. Negative 16 minus 12 is negative 28. And then the inside part of this integral would be these parentheses would be negative 9 as well, because this cancels out with this, similar to the first step over here, and we get negative 9. And then we just continue, so we get 18, because this becomes positive 9. 9 plus 9 is 18, minus 28 plus 64 over 3. And this is equal to negative 10 plus 64 over 3. And then we can rewrite this as negative 30 over 3 plus 64 over 3. And our final answer is going to be 34 over 3. Yeah, that's the final answer for this first question. So for the second question, it says, find the values of c guaranteed by the mean value theorem for integrals for the function over the given interval. And then we have the function and the interval. So the first step is to write down the formula. So the integral from negative pi over 6 to pi over 6, cosine x minus pi over 3 times dx. And this is going to be equal to f of c times b minus a times b minus a. In this case, b minus a would be pi over 6 minus negative pi over 6, which is pi over 6 plus pi over 6, which is pi over 3. And then we just have to solve this left-hand side, and then to progress with the next step. So for this integral, we're going to take the antiderivative of this. So that would be sine x minus pi over 3x. And then we can plug in the values here. So sine of pi over 6 minus pi over 3 times pi over 6, which is pi over 18. Or sorry, pi squared over 18. And then we subtract for the lower limit. So it would be sine of negative pi over 6 times or plus pi over 18. And then we can continue simplifying. So sine of pi over 6 is equal to 1/2 minus pi squared over 18. And then sine of negative pi over 6 would be negative 1/2, because that's in the fourth quadrant, and that's where sine is negative. So minus negative 1/2 plus, sorry, this is also pi squared over 18, plus pi squared over 18. And then it would just be 1/2 minus pi squared over 18, pi squared over 18, plus 1/2 minus this. And then we get 1 minus 2 pi squared over 18, which is just pi squared over 9. Okay, so we evaluated this left-hand side, and that's going to equal to f of c times pi over 3. So we can now we can solve for the value of c. So we have 1 minus pi squared over 9 is equal to f of c. So f of c in this case is going to be cosine c minus pi over 3 times pi over 3. And then we can multiply by the reciprocal. So the better step would be to get the common denominator. So that would be 9 minus pi over 2 over 9, and then we can multiply by 3 over pi, which is equal to cosine c minus pi over 3. This would cancel out and we get this. So this is equal to 9 minus pi squared over 3 pi. And we add the pi over 3 in the next step. So cosine c is equal to 9 minus pi squared over 3 pi. And then we add pi over 3. So we can do the common denominator in the same step. So that'd be plus pi squared over pi over 3. And then notice how these two cancel out. So we're left with 9 plus 9 over 3 pi, which is equal to 3 over pi. So then we can take the cosine inverse. So c is going to equal to cosine inverse of 3 over pi. And this, if you have a scientific calculator permitted, this would be equal to 0.301. If you don't, then you can leave your answer as cosine inverse of 3 over pi. But also notice how this question says find all values. So there could be multiple values of c in this case, because there's different values for which there's different radian values or angle values that give you the same side length of 3 over same side length or same x value of 3 over pi. So cosine is going to be positive in both quadrant 1 and quadrant 4. So in this case, our angle is going to be 0.301 radians here, but negative 0.301 radians is also going to give you the same x value because cosine is positive in both of these quadrants. So c is also going to be equal to negative cosine and then 3 over pi, which is equal to negative 0.301. So that's going to be our final answer. Okay, so for the last question, it says the continuous graph of f of t is shown below, and let h of x equal that integral. Find h of 3, h of negative 2, and h prime of 5. On what intervals is h of x decreasing, and what x coordinates does h of x have a point of inflection at? So first, we have to find h of 3. So h of 3 is going to be the area that's bounded by the function and the y-axis, the x-axis, and x equals 3 over here. So this is the area that we need to find for h equals 3. So we can split this quadrilateral up into a triangle and then a trapezoid. So for the triangle portion, which is going to be this portion, our area would be h of 3, or first let's write it in the notation. So h of 3 is equal to 0 to 3 f of t times d of t dt. So this is going to equal to the area underneath that's bounded by the x-axis and with these limits and h of x, or sorry, f of t. So so back to the area. So we have a negative area for this triangle over here. So it'd be negative 1/2. The base is going to be 1 times height, which is going to be negative 3. Well, in this case, we don't need a negative twice. So times 3. And then the area for the trapezoid part, so from here to here, would be so we have -3 as one of the bases, and then we have -2 as the other base. So we can add those two together, divide them by 2. So you're finding the average of two of the bases, and then you're going to multiply this by the height, which is going to be 3 minus 1, which is 2. So then you can multiply. We get -3 over 2. These two cancel out. So it would be -5. And then for common denominator, once we get the common denominator, it'd be -13 over 2. So that's going to be the answer to, that's going to be what h of 3 is going to equal to. Now for h of -2, we do a similar process where we rewrite the integral 0 -2 f of t times dt. Okay, so for this integral, notice how the lower limit is 0 and the upper limit is -2. So in this case, it's sort of flipped in the sense that the upper limit is less than the lower limit. So in order to change that and flip them, we have to multiply this by -1, this entire integral. So this is going to be equal to this. And now once we do this, we can evaluate like the area, this triangle area from here normally, like how we normally would. So this is going to equal to negative, so the 1/2, so the base is going to be 2. -1/2 base is 2 times the height, which is 6. So -1/2 base times height. So that would be equal to -6 for h of -2. And then for the last part of it, okay, for the last part of it, we have to find h prime of 5. So so this graph shows f of t, but f of t is essentially the same thing as h prime of x, and here's why. If we take this integral over here and take the derivative of both sides, it'd be d times this h of x, which is also equal to h prime of x. And then using the second fundamental theorem of calculus, the right hand side is equal to f of x, which is what this graph is showing. F of t, f of x is going to be the same thing. So h of x, h prime of x is going to equal to f of x. So that's what the graph is showing. So if we want to find h prime of 5, we can just go to the x value 5 and find the y value here, which is going to be 2.5. Yeah. So next part is going to be finding on what interval h of x is decreasing. So h of x is going to be decreasing where h prime of x is less than 0. So on whatever intervals h prime of x is less than 0 on this function, that's where h of x is going to be decreasing. So that is going to be from 0, and then there's another point over here but we have to find that because it's not clear on the graph. So we know that the slope of this line is 4 because we can count, and if we do rise over run, we can count that it's 4 and then 1. So the slope of this line is equal to 4. But from this point to the x-axis, we have a rise of 1.5. This is what we're trying to find. So we know the slope is equal to 4. So 1.5 rise over run is equal to 4. And then if we just rearrange, we get 1.5 over 4 is equal to x, which is equal to 0.375. So that's what this value is going to be. So then we can add 4 to that. And then we get that the interval is going to be, where it's decreasing, is going to be from 0 to 4.375. And the last question is, and what x coordinates does h of x have a point of inflection at? So on this graph, we have only one point where the function changes from increasing to decreasing, which is going to be over at where x equals 10, 1. So this is, at this point is where we're going to have a point of inflection, because remember this represents h prime of x. So h of x would have a POI where h prime of x has a relative max or min, and where h double prime of x, which isn't shown, has a x-intercept. So h prime of x would have an x-intercept, h double prime of x would have an x-intercept, h prime of x would have a relative max or min, and h prime of x would have a point of inflection. So the point of inflection would be located at x equals 1 in this case. X equals 1. So yeah, that's about it for this video. So I hope you enjoy learned something from this video about integrals and definite integrals, and yeah, that's about it. Thank you for watching.